All right, so tomorrow we're going to be continuing with some more solving some algebra equations, but the ones that I'm going to have you work on tomorrow are ones that tend to scare students, namely ones that involve fractions, and then actually on the next page, ones that involve decimals as well. And so I'm just going to talk about the two strategies, one for fractions, one for decimals, that you can use to in order to get rid of the fractions or decimals immediately, as opposed to just skipping the problems, which is what students tend to do in general. All right, so you guys can read. So it really is a couple of it's two steps. Figure out what the LCD is, the least common denominator is, and multiply by it. I guess I'm counting that as one step. Then you have a fraction. You have a problem that is a standard algebra problem that does not have any fractions in it, so you're good to go. So the first example here, this guy right here, there's only one fraction. All right, so the least common denominator's got to be the only denominator in the problem. So I'll type instead of write. The LCD is equal to 4 in this case. All right, so you just multiply both sides by 4, and that's it. Well, it's not it, but the hard part's done. The intimidating part of the problem has gone away. So you multiply both sides by 4. So times, that's supposed to be times, times 4. Okay? So you get just 5x on the right, because the whole point is these cross cancel. Okay? Or you can think of it as, I won't write it out, but you think of this as 4 over 1, so you do 4 times 5 is 20, 1 times 4 is 4, so it's 20 over 4, which is 5. And then you just get 60 on the right. So you get 5x equals 60, so that means x has to equal 12. You can check your work. If you plug 12 in here, do 5 over 4 divided by 12, it should work out to be 15. So it should work out. So there you go. X equals 12. Now here, the LCD is not so easy to figure out. It's not just staring you in the face like the previous problem, but it's not that bad. The trick is you see the fractions, just multiply all the denominators together. That will give you, well, it might not give you the least common denominator, but it'll give you a common denominator. And that's really all you need. Okay? If it's the least common denominator, then super. You have smaller numbers to work with. But if it's just a common denominator, it'll still work. And the way to figure it out is you do LCD is what are all the denominators? There's a 3 and a 5, so it's 15. And it is actually the least common denominator in this particular example. So when you do what I just did, it doesn't always give you the LCD, but this time it happens to do so. And so you multiply both sides by the 15. Notice what I'm writing here, trying to write. When you multiply both sides of an equation by something, you've got to remember it's the entire side. So since this involves two terms here, okay, you have to distribute. Okay, we're going to do the example I'm going to do on the next page might seem to contradict that, but hopefully I explain it well enough that it's not confusing. But here, yeah, you've got two terms, multiply both of them by 15. So you have, this works out to be 35. All right. So you get 35 on the left, x. Okay, so you do 15 times 7 over 3. Or you could cross cancel here and get a 5. So it's 5 times 7 is 35. That's maybe the better way to explain it. And so here, the 15 has to distribute, so you have a 45, 3 times 15, and then when you multiply this out, you get 24x. Okay? And then now it's just a regular Algebra 1 problem. Now it's fine. So, and I picked the numbers poorly. I thought it worked out well, but oops, apparently I did. Apparently I'm not very good at math because it doesn't work out that nicely. Add 24 to both sides. Excuse me, 24x is what I should say. And you get 49. Yeah, I'm not good at math. That is not right. You get 59. X equals 45. And so x is this fraction, which is not to reduce, I don't think, because I'm pretty sure 59 is a prime number, so it's not going to reduce. So there you go, it's just that fraction. And go ahead and leave it in fraction. Don't panic and think you got to use it, put it in decimal form or anything. This is totally a-okay. 45 over 59. All right, so speaking of decimals, all right, what are there's decimals? And if you don't mind working with decimals, that's fine, really. We did an example on Friday, and some people were cool with trying to work with the decimals, and it's no big deal. But if you hate using decimals, then it's a similar trick. You just multiply what makes it so that the decimals go away. In this case, basically you just got to multiply by powers of 10 on either side of the equation. So you multiply by powers of 10. Well, what power of 10 specifically? Well, if I multiply by 10, it'll move the decimal point once. It's been a while since maybe you guys have thought about that. It's I don't remember where you learned this kind of thing, but not in a while. But the idea is every time you multiply by 10, it moves the decimal point once. So if you multiply by 10 twice, so you multiply times 10 and then times 10 again, well, that's silly. That's multiplying by 100. Okay. Then what happens is that now there's no decimals. Okay. So in this case, there are two decimals. Boom, boom. So I got to multiply by 100, and that will get rid of any sort of decimal situation. So times 100 times 100. Okay. Let me do the right side first. So you multiply 0.01 times 100. Boom. That's 1x. And then 2 times 100. That's 200. Okay. 100 times 0.01. How do you get 1? Well, just remember when you multiply by powers of 10, so 100 squared or 10 squared is a power of 10. You move it once for every exponent. 100 is 10 squared, so squared means 2. Move it once, twice, so it's 1x. All right. On the left side, do the same thing. Now, one thing that's potentially confusing is that there's actually really kind of only two terms here. The first term is this big complicated guy right here. And then the second term is the 3. So you do 100 times 0.02, and it's 2, and the x minus 20 plus 300. And then from here on out, it's kind of a regular standard problem. The only thing you have to really, that's a little weird, is that you have to distribute the 2. You guys should be okay with that. There's definitely problems that we practiced on Friday that you had to do with that. Do that. And then minus x, and then this is negative 260. Whoa, positive 260. I'm sorry. It's 300 minus 40. 300 minus 40. So I'm going to add a 260 to both sides. Okay. So subtracting x, adding 260 because that's what this is. So, and you get. Oh, hey, that's not what you get. you get 1x, works out awfully nicely, equals 460. And then you guys can check that and verify that, yeah, that works out just fine if you put it back into the original problem. Alright, so there you go. That's it. That's how you handle fractions and decimals. Hopefully that's helpful. I would recommend checking and making sure these work out okay. By plugging numbers in, I might check that tomorrow as I do now. Hint, hint, hint.